In the 1980s, Pascal was the language taught in universities worldwide. It was elegant, structured, and designed specifically for teaching good programming practices. Yet today, it has nearly vanished from the programming landscape. While C++ dominates systems programming, game development, and high-performance applications. What happened? Pascal emerged in 1970, created by Niklaus Wirth as a teaching language. Its clean syntax and strong typing made it perfect for learning programming fundamentals. By the early 80s, Pascal had become the standard language in computer science education. Students learned to think systematically, write readable code, and avoid common programming pitfalls. But Pascal's strength as a teaching language became its weakness in the real world. The language was designed with specific constraints that made sense in academia, but proved limiting in professional software development. Pascal lacked low-level memory manipulation features that systems programmers needed. It couldn't easily interface with operating system functions or hardware. The fragmentation problem made things worse. Different vendors created their own Pascal variants. Borland had Turbo Pascal. Apple had Object Pascal. Each implementation added features the original language lacked, but these extensions were incompatible with each other. A program written for one Pascal compiler often wouldn't run on another. This fragmentation meant developers couldn't rely on Pascal for portable professional software. Meanwhile, C had been quietly growing in the Unix world. Developed at Bell Labs in the early 70s, C gave programmers direct access to memory and hardware, while still providing high-level abstractions. The Unix operating system itself was written in C, proving the language could handle serious systems programming. When Bjarne Stroustrup created C++ in the early 80s, he built it as an extension of C, not a replacement. This backward compatibility was crucial. Existing C code could work in C++ programs. Libraries written in C could be used directly. Companies didn't have to throw away their investments in C code bases. They could gradually adopt object-oriented features while keeping their existing code running. This evolutionary approach made C++ far less risky to adopt than switching to Pascal. C++ also offered power that Pascal couldn't match. Templates allowed generic programming. Multiple inheritance provided flexibility in object-oriented design. Operator overloading let programmers create intuitive interfaces. These features made C++ suitable for complex applications like operating systems, databases, and game engines. The industry backing told the story. Major compiler vendors like Microsoft, Borland, and GNU invested heavily in C++ tooling. Standards committees worked to create a unified language specification. By 1998, C++ had an international standard that ensured code portability across platforms. Pascal never achieved this level of industry coordination. Universities eventually followed industry's lead. As companies demanded C++ skills, computer science programs shifted their curricula. The language that had once been too complex for beginners became the new standard. Pascal's role as the premier teaching language evaporated. Pascal didn't disappear entirely. Delphi, based on Object Pascal, still has a dedicated following for rapid application development. Free Pascal continues to be maintained. But these are niche uses compared to C++'s dominance in performance-critical software. The lesson here extends beyond programming languages. Pascal lost because it prioritized purity over practicality. It valued teaching correctness over solving real-world problems. C++ won because it met developers where they were, provided the power they needed, and had the industry support to become a true standard. In technology, The most elegant solution doesn't always win. The one that solves actual problems does.